Compound angle worksheet exercise number 1, question number 1, sub question 1. Tan 105. Now 105, okay. This particular value we need to find out using the functions of 45 and 60. So tan 45 plus 60. Okay. So this is A and this is B. Tan A plus tan B. 1 minus tan A tan B. That formula I've used. And tan 45 is 1 and tan 60 is root 3. So this is how you calculate. You can rationalize this further. Second sub question. Cos 345. 300 plus 45. That's given in the problem. So cos A plus B. Cos A cos B minus sin A sin B. Put the respective values. Cos 45 is 1 by root 2. Cos 300. 300 divided by 90. 93s are 270. Remainder is 30. So cos 3 into pi by 2 plus 30. So 3 pi by 2 is over here plus anti-clockwise direction. In this quadrant, cos is positive. Cos changes to sine because 3 pi by 2 lies on the y-axis. So it is sine 30, which is equal to half. So this value will substitute over here. Now sine 300. Again, sine 3 pi by 2 plus 30. In the fourth quadrant, sine is negative. Y-axis 3 pi by 2 is in the y-axis. Sine changes to cos minus cos 30 minus root 3 by 2. So let's put this value over here. So this will be 1 plus root 3 upon 2 root 2. Third, cosec 13 pi by 12. Cosec 13 into 180 by 12. This thing you need to calculate using a calculator, or you can also do it manually. Okay. So you do that. So that's 195. Which is equal to 1 upon sine 195. 195 divided by 90. 92 is 180. So this is 15. So 1 upon sine 2 pi by 2 plus 15. 2 pi by 2 is negative x-axis plus anti-clockwise direction. In this quadrant, your sign is negative and 2 pi by 2. X-axis, sign remains sine 15. So minus 1 upon sine 15 minus 1 upon sine 15, which can be written as 45 minus 30 or 60 minus 45. So now you apply the formula, it is sine A minus B. You'll get some value in the denominator. Okay. If you want, you can rationalize. Next problem. Question number 2, sub question 1. Sin 80 cos 20 minus cos 80 sin 20. So this is A, this is B, this is A, and this is B. Now, if you read the question, they are asking you to reduce it to a single term. So sin A minus B you will use sin A cos B minus cos A sin B. So that is sin A minus B, which is equal to sin 60. Now, if your teachers are asking you to calculate this, you just put the value of this. Second, cos theta plus alpha, cos theta minus alpha, sin theta plus alpha, sin theta minus alpha. So this is A, this is B, this is A, and this is B. So cos A cos B minus sin A sin B is cos A plus B, if you remember the formula. Alpha alpha will get cancelled, so this will be cos 2 theta. Third, tan 69, tan 66. Okay, this is the question. So this is A, this is B, this is A, and this is B. So tan A plus tan B upon 1 minus tan A tan B is tan A plus B. Tan 69 plus 66, which is equal to tan 135. Now you can do divide by 90 method and solve this problem. Sub question 4, tan alpha minus tan alpha minus beta, 1 plus tan alpha minus beta. So this is A, this is B, this is A, and this is B. So this is tan A minus B. The round brackets are important because there is a minus sign over here. So it's tan A minus B. Tan A minus tan B upon 1 plus tan A tan B is tan A minus B. So alpha alpha is getting cancelled. We are left with minus into minus is plus tan beta. Three sub question 1. Okay. So there are two terms over here. Sin alpha cos beta plus cos alpha sin beta, the whole square, plus cos alpha cos beta minus sin alpha sin beta, the whole square. So this is sin alpha plus beta, the whole square. It's a direct formula, sin A cos B plus cos A sin B. And this is cos A cos B minus sin A sin B. So this is going to be cos alpha plus beta. So sin square alpha plus beta plus cos square alpha plus beta equal to 1. Next one, sin 60 plus theta, sin 60 minus theta. Now this also can be solved using factorization formula, but then that is the next part of the chapter. We'll simply use compound angle formula with brackets because there is a minus sign in between. So sin A cos B cos A sin B, sin A cos B cos A sin B, root 3 by 2 cos theta, half sin theta, open the brackets, root 3 by 2 cos theta, minus into minus is plus, half sin theta. So there will be some cancellations. Half sin theta plus half sin theta is equal to sin theta, which is equal to RHS. Hence proof. Okay. Third sub question. First, I'll calculate tan 240 plus theta, which is equal to sine 240 plus theta, sine 240 cos theta, cos 240 sine theta. Now, this values you are going to calculate using divide by 90 method, separately do that, and you'll get this particular value. Similarly, you have to calculate this using compound angle formula. Okay, you'll get another value. Now, this value and this value are supposed to add because there is a plus sign in the LHS in between. So this I'll leave it up to you. Next one, fourth, sine A minus 45, sine A cos 45, compound angle formula minus cos A sine 45. So sine A 1 by root 2, cos A 1 by root 2. Take 1 by root 2 common, sine A minus cos A. This is equal to your RHS. We started with LHS. Okay. Question number 5, cos pi by 3 plus x, cos 60 plus x. Okay. Now you use this formula, compound angle formula, you'll get the RHS. Sixth one, tan 45 minus theta. Tan 45 minus tan theta, 1 plus tan 45 tan theta, 1 minus tan 45, 1 plus tan 1 minus tan theta, 1 plus tan theta, because tan 45 is 1. Hence proved. Seventh one, sin theta minus phi, sin theta sin phi. In the numerator, use compound angle formula. Sin theta cos phi minus cos theta sin phi, sin theta sin phi. Okay, so this upon this, sin is getting cancelled. Cos upon sin is cot phi minus this upon this. Sin phi is getting cancelled. Cos theta upon sin theta is cot theta. So this is equal to your RHS. Let's go to question number 4. So sin A minus B upon sin A sin B equal to sin A cos B minus cos A sin B upon sin A sin B. So this upon this, sin will get cancelled. Okay, so this is cot B minus this upon this. Sin is getting cancelled. Cot A upon sin is cos A upon sin is cot A. So this became this. So we can write similarly because the pattern is same. So sin B minus C upon sin B sin C. So this became cot B minus cot A. So this will become cot C minus cot B. Okay. Further, sin C minus A upon sin C sin A. Okay. This also we can directly write similarly as cot A minus cot C. Now we have to add all these terms because there is a plus sign between all this. All the sums will get all the terms will get cancelled. And we'll get the answer as 0. Question number 5. Okay. So we are supposed to calculate this. So calculate this individually. Sin 60 plus 45. Use sin A plus B formula. You'll get a specific answer. This also cos 60 plus 45. You can do it separately also and then add. And use compound angle formula. Add the terms. The final answer should be 1 by root 2 because we are supposed to prove cos 45. Okay. Question number 6, sub question 1. Cos alpha is equal to minus 12 by 13. Cot beta is equal to 24 by 7. Alpha is in the quadrant number 2 and beta is in quadrant number 3. So by triangle method, if this is alpha, cos is adjacent upon hypotenuse. So this will be 5. So sin alpha will be 5 by 13 and the positive sign will be there because sin is positive in the third quadrant. Okay. This is beta. Cot beta is this. So tan beta is 7 upon 24. Opposite upon adjacent. So the hypotenuse by Pythagoras theorem will be 25. So calculate sin beta. Sin beta will be 7 upon 25 with a negative sign because it's a third quadrant. Cos beta is equal to minus 24 by 25. Okay. Third quadrant. Right. Now first we are going to calculate sin alpha plus beta, which is equal to sin alpha cos beta, cos alpha sin beta. All these values we have already calculated using triangle method. Okay. Sin, cos, all the values we have. Okay. That you can put it in the formula and get the answer. Cos alpha plus beta, cos alpha cos beta minus sin alpha sin beta. Again, you have all the values. And then tan alpha plus beta, you can use compound angle formula, or it will be simple sin alpha plus beta upon cos alpha plus beta. Okay. So this is how you need to solve this particular problem. Question number 7. Sub question 1. A and B are acute angles. They are lying in the first quadrant. Sin A is 1 by root 5. Sin B is 1 by root 10. Okay. So now this is A, this is 1 and this is root 5. Opposite upon hypotenuse. So by Pythagoras theorem, this will be 2. And this is 1, this is root 10. So by Pythagoras theorem, this will be 3. Okay. So cos A and cos B, I'll just calculate. Both will be positive because A and B are acute. 2 by root 5, 3 by root 10. Okay. Now they're asking A plus B, the value of A plus B. A and B are angles, so A plus B will also be an angle. So acute plus acute is acute. Okay. And acute plus acute can also be obtuse. It can go in the second quadrant as well. So what we'll do over here is case 1. A plus B is less than 90. Okay, that will assume. So first we'll calculate sin A plus B, which is sin A cos B plus cos A sin B. So sin A That is 1 by root 5 and 2 by root 5. One second. Cos B is 3 by root 10, I guess. One second, let me just check. Yeah, and 1 by root 10 into 2 by root 5. So this is 2 by root 5 and 1 by root 10. Okay. So 3 plus 2 is 5, root 5, root 10. We took LCM. 5 upon root 5 is root 5. Root 10, I'll write root 10 as root 2 into root 5. So this is gone 1 by root 2. So sine A plus B is 1 by root 2, which is equal to sine 45. Okay. So A plus B is also A plus B is 45. So this was the solution for the first quadrant. Less than 90. Total is less than 90. So the solution for the first quadrant is 45 degree. Now sine B is sine 45. Sine is positive. Okay. Sine 45 is positive. So first quadrant solution is there. Case 2. A plus B can be greater than 90 also in the second quadrant. Acute plus acute can also be obtuse. Right? So sine plus sine 45. Okay, so sine should remain sine. So we will go on the x-axis, and to go on the second quadrant, we'll have to subtract 180 minus. So sine 180 minus 45. See, because sine 180 minus 45 is also sine 45 by this particular method. Okay. So sine A plus B is equal to sine 135. So A plus B can also be 135. Fine. Question number 7, sub question 2. Tan A is equal to 5 by 6. Tan B is equal to 1 by 11. Okay. Now guys, A and B are acute. Okay. In this problem, we cannot take the second case. So acute plus acute will be acute only. We cannot take go in the second quadrant. The only reason is tan is positive. So tan is positive in the first and the third quadrant. But then can the total of A and B go in the third quadrant? No, because acute plus acute is less than 180. It can go in the second quadrant. It can definitely not go in the third quadrant. Addition of two acute angles. But in second quadrant also we will not consider because tan values are positive and tan is not positive in the second quadrant. Okay, right? So that's a very critical point over here. So tan A plus B, tan A plus tan B, 1 minus tan A tan B, 5 by 6 plus 1 by 11, 1 minus 5 by 6 into 1 by 11. So tan A plus B, if you solve this, you'll get this as 1 by taking LCM and all. Tan A plus B is equal to tan 45. Tan 45 is 1. Oh, sorry. So therefore, A plus B is equal to 45 degrees. Okay. Let's go to question number 8. Tan alpha is equal to m upon m plus 1 tan beta is equal to 1 upon 2m plus 1. Okay. So this problem had an error in the question. We need to find out the value of tan alpha plus beta. So tan alpha plus beta is equal to tan alpha plus tan beta 1 minus tan alpha into tan beta m into m plus 1 plus 1 upon 2m plus 1 1 minus m into m plus 1 1 upon 2m plus 1. So this will be LCM over here. So m into 2m plus 1 plus 1 into 2 1 plus 1 into m plus 1 upon m plus 1 2m plus 1, and these two terms will go over here, m plus 1 to m plus 1 minus 1 upon m plus 1 to m plus 1. So this and this is gone. 2m square plus m plus m plus 1. This will be 2m square plus 2m minus m. Just a second. 2m square minus m plus 2m is m minus 1, and this is also minus 1. Okay. Just let me confirm the question whether this is correct or wrong. Okay. Give me a second. Yeah, this is correct. So let me just go back. M into 2m plus 1 plus m into 1 into m plus 1. M into 2m plus 1 plus 1 into m plus 1. Okay, and down it is, yeah, so this is plus 1. So I think I made a mistake over here, plus 1. Fine. Okay. So this will be multiplication of these two brackets is this. Fine. Just a second, I'll just redo this. 2m square plus m plus 1, and down it is 2m square plus m plus 2m plus 1 minus 1. Okay. So 2m square plus 2m plus 1 upon 2m square plus 3m. So basically this also should be m. I forgot to write one m over here. Okay. So this has to be m. So this m and this m is gone. So this is equal to 2m square plus 2m plus 1 upon 2m square plus 2m plus 1. So we got the value of tan alpha plus beta. Tan alpha plus beta is equal to 1. Tan alpha plus beta is equal to tan 45. Alpha plus beta is equal to 45. Hence proved. Okay. Or rather, we just find out we have got a value of alpha plus beta. Now, like the previous problem, they have not said alpha and beta in the quadrant at all, quadrant number 1, 2, anything. So let's do only one case over here. Fine. So let's go to question number 9. A lengthy problem. We have triangle ABC. Foot of A to BC is D. This is D. Okay. Tan B. Tan B is equal to 4 by 3. So B is over here. Okay. So let this be 4x and 3x. The common multiple is x. It's a ratio, right? Okay. So for B, what is the opposite side? It is 4x. And what is the adjacent side? It is 3x. Okay. And AB is 20. Right? So this is equivalent to AD upon BD, right? So AD is 4x, BD is 3x. That's how we calculate. Then Pythagoras theorem, 4x the whole square, 3x the whole square is equal to 20 square, this triangle. 16x square plus 9x square is equal to 400. 25x square is equal to 400. X square is equal to 16. Okay. Therefore, x is equal to 4. Let's not take minus 4 because these are lengths. Therefore, BD is 3 into x. So 3 into 4, which is 12. AD 4 into x. 4 into 4, which is 16. Okay. Then we got this length. One more ratio is given. Cos C 15 by 17. So C is over here. Cos C is 15 by 17. So 15y upon 17y. Let the common multiple here be y. So cos C is adjacent upon hypo. So this is 15y and this is 17y. Okay. Adjacent to C is DC, which is 15y, and hypotenuse is 17y. So 16 square, this is 16, right? 16 square plus 15y the whole square equal to 17y the whole square. Okay. 16 square plus 15y the whole square, 17y the whole square. 256, 289y square, 225y square. 256 is equal to 64 y square. So y square is equal to 4. Okay. So y is equal to 2. And since y is equal to 2, okay, since y is equal to 2, this is going to be 30 and this is going to be 34. Okay. So now we have all the lengths. Okay. Now they're asking length of side BC. So BC is this plus this, which is 42. Whatever units are there, you can put. And AC as well. AC is 34, which we have already calculated. Fine. Yeah. Now see, sine A, the value of sine A. Now A is the entire angle. So we'll break down A into alpha and beta. A is nothing but BAC. So A is the total of two angles, alpha and beta. Alpha is equal to BAD, angle BAD, and beta is equal to angle CAD. Okay. So in triangle ABD, in triangle ABD, sine alpha is equal to opposite upon hypo, 12 upon 20. In triangle CBD, in triangle CBD, CAD rather, sorry, in triangle CAD, sine beta is here, it's opposite upon hypo, 30 upon 34, 15 upon 17. Cos alpha and cos beta also will calculate from the same triangle. So cos alpha over here in this triangle, okay, cos alpha in angle ABD, triangle ABD is 16 upon 20, adjacent upon hypo, 16 upon 20, 4 by 5, and cos beta 16 upon 34, adjacent upon hypo, 16 upon 34. So we got a values of cos beta. Now sine A is the addition of two angles, alpha plus beta, because when I say A, it is entire BAC. So BAC is equal to alpha plus beta. Now you apply compound angle formula over here. Sin alpha cos beta, cos alpha sin beta. You may put the values and get the answer. Let's go to question number 10. Okay. Tan A plus B is equal to 1, right? And tan A minus B is equal to 1 by 7. So this is equal to tan A plus tan B upon 1 minus tan A tan B equal to 1. So tan A plus tan B equal to 1 minus tan A tan B. I simply cross multiplied this over here. Okay. Second case, tan A minus B is 1 by 7. So tan A minus tan B upon 1 plus tan B, tan A tan B equal to 1 by 7. So 7 tan A plus 7 tan B, 1 plus tan A tan B. Equation 1, equation 2. Okay. Now first we'll add 1 and 2 so that this term will get cancelled. Okay. So add 1 and 2. So when we add 1 and 2, tan A plus 7 tan A is 8 tan A. Tan B plus 7 tan B is, I think so it should be minus, sorry. This was supposed to be minus. So tan B minus 7 tan B is equal to minus 6 tan B equal to this and this term is gone. 1 plus 1 is 2. So divide by 2 throughout. 4 tan A minus 3 tan B equal to 3. So either you write tan A in terms of tan B or tan B in terms of tan A. So I'll write 4 tan A is equal to, I think this should be 1. 1 plus 3 tan B. So tan A is equal to 1 plus 3 tan B upon 4. Okay. Let this be equation number 3. Now you put this value in any one of the equations, equation 1 or 2. So I'm putting this value of 3 in equation number 1. So tan A is equal to 1 plus 3 tan B upon 4 plus tan B. Tan B will remain tan B equal to 1 minus tan A tan B. So again, I'm going to put the value of tan A over here. 1 plus 3 tan B upon 4. Take LCM on both left hand side, right hand side. 1 plus 3 tan B plus 4 tan B upon 4. 4 minus tan B minus 3 tan B tan square B, because you're multiplying this with both the terms over here, and take the minus sign inside also, and this also will be 4. So 4 and 4 is getting cancelled. So 3 tan square B, 3 tan square B, 3 tan B plus tan B is 4 tan B, and 1 minus 4 is minus 3, which is equal to 0. Okay, right? Let me just take a look whether I've gone wrong somewhere. One plus 3 tan B upon 4 plus tan B is 1 minus tan A tan B. 1 plus 3 tan B upon 4. So 4 over there. Three times square B. Okay, now there is one more 4 tan B over here. I just forgot that. Somehow it got left. Okay, so 3 tan B plus 4 tan B, 7 tan B plus tan B, which is equal to 8 tan B. Okay, and 1 minus 4 is minus 3. So minus 9 we required. 3 into minus 3 is minus 9. So 9 into 1 plus 1 plus 9 minus 1. So 3 tan square B plus 9 tan B minus tan B minus 3 equal to 0. So take 3 tan B over here common. 3 tan B common. So it will be tan B plus 3 within the bracket. Minus 3 common I'll take. No, minus 1 common I'll take, and tan B plus 3. Sorry. So 3 tan B minus 1, tan B plus 3 equal to 0. So tan B equal to 1 by 3, or tan B equal to minus 3. Okay. Now this value you put where? In the value of tan A. That is equation number 3. Tan A is equal to 1 plus 3 tan B upon 4. And here also tan A is equal to 1 plus 3 tan B upon 4. Put the values of tan B. Put the values of tan B and calculate the answer. Okay, so there will be two cases. Question number 11. Okay. Question number 11 says tan A plus B is equal to x. Tan B is equal to half. So tan A plus B, tan A plus tan B, 1 minus tan A plus tan B. So tan A plus B is equal to x. Tan A plus half, 1 minus tan A into half. Take LCM, 2 plus tan A upon 2. Sorry, 2 tan A plus 1 upon 2. And 2 minus tan A upon 2. Okay. So this and this is gone. So x is equal to 2 tan A plus 1 upon 2 minus tan A. We need to find out the value of tan A. So I'll just cross multiply this and this. So 2x minus x tan A is equal to 2 tan A plus 1. Take tan terms together and non-tan terms together. So this and this term I'm grouping 2 tan A plus x tan A. So 2x minus 1, take tan A common, 2 plus x. So tan A is equal to 2x minus 1 upon 2 plus x. Okay. Just a second. Uh, yeah, so this should be plus over here. Fine. Now tan A minus B in terms of x. So tan A minus B, tan A minus tan B, 1 plus tan A tan B. Now tan A we have already calculated 2x minus 1 upon x minus 2, x plus 2, sorry. Tan B is half, 1 plus 2x minus 1 upon x plus 2 into half. So this will be 4x minus 2 minus x minus 2. Okay. And this is going to be 2x plus 4 plus 2x minus 1. Okay. I took LCM, and once we take LCM, this terms will get cancelled after taking LCM. Okay. So this is going to be 3x minus 4 upon 4x plus 3. Okay. So that's the value of tan A minus B. Now they are saying tan A minus B is equal to 1 by 3. So now this part we have proved. We have got tan A minus B. They were asking us to calculate tan A minus B in terms of x. That we have done. Okay. Now tan A minus B is 1 by 3. This is 1 by 3. So this will be equated to 1 by 3. 1 by 3 is equal to 3x minus 4, 4x plus 3. So 4x plus 3 is equal to 9x minus 12. 15 is equal to 5x, x is equal to 3. Okay. So they are asking you find A without using tables. Now A is what? Angle. But in tan A we have calculated now 2x minus 1 upon x plus 2. So put 3 over there. So 5 upon 5, this is 1. Tan A equal to 1. Therefore, A is equal to 45 degrees. A is equal to 45 degrees. Question number 12. Okay. Sin alpha plus beta and sin alpha minus beta are given. So tan 2 alpha is equal to tan alpha plus alpha. Add beta, subtract beta. Okay. So this is what we have got, which is equal to, let this be A, let this be B. Tan A plus tan B, 1 minus tan A tan B. Okay. Now sin alpha plus beta is equal to 4 by 5. They have said that alpha and beta are in, alpha plus beta and alpha minus beta are acute. So alpha plus beta is acute. So only first quadrant. Okay. So this is 4, this is 5, this is 3. So what will be tan alpha plus beta? Tan alpha plus beta will be 4 by 3. So this value is 4 by 3. Similarly, this value you calculate tan alpha minus beta from sin alpha minus beta using triangle method. Okay. So sin alpha minus beta is equal to 5 by 13. 5 and 13. So this will be 12. This angle is alpha minus beta. Okay. This was alpha plus beta. Fine. So sin alpha minus beta. Look at the triangle and tell me what is sin alpha plus minus beta. It will be 5 by 12. Okay. Sorry, it will be sin alpha minus beta is 5 by 13. Tan alpha minus beta will be 5 by 12. So these values we have, you can put it over here and prove. Question number 13. Okay. 1 plus tan 2 theta into tan theta. So 1 plus sin 2 theta upon cos 2 theta into sin theta upon cos theta. Take LCM. Cos 2 theta cos theta. Sin 2 theta sin theta upon cos 2 theta cos theta. Now this is A, this is B, this is A, this is B. 2 theta minus theta. Cos 2 theta minus theta is cos theta. Okay, and this cos 2 theta. So one term will get cancelled. Take this term up in the numerator, hence proved. Question number 14. There are many terms. I'll solve each term separately. Sin pi by 3 minus theta. Sin 60 minus theta. Sin 60 cos theta. Sin 60 cos theta minus cos 60 sin theta, root 3 by 2 cos theta, half sin theta. Then sin pi by 3 plus theta, sin 60 plus theta. So if you solve this using compound angle, it will be same. Okay. Now left hand side, 4 into this, but then the value of this we have calculated, root 3 cos theta minus half sin theta, root 3 by 2 cos theta, half sin theta. Now this is of the format a minus b into a plus b. So it is a square minus b square. So 4 into a square minus b square Okay, so 4 into 3 cos square theta minus sin square theta upon 4. 4 is getting cancelled. See, we have a common denominator 4 because 2 square is 4 for both the terms. Okay, now right hand side we don't require a cos term. So eliminate this cos square by 1 minus sin square by 1 minus sin square. So 3 minus 3 sin square theta minus sin square theta. This is going to be minus 4 sin square theta. Hence proved. Okay. Let's go to question number 15. Okay. 17 and 62 are related to each other with a standard angle. So I'll start with this in this manner. 45 plus 17 is equal to 62. Taking tan on both the sides. Tan A plus B. Tan A plus tan B. 1 minus tan A tan B. Tan 62. Tan 45 is 1. 1 plus tan 17. 1 minus tan 17. Now convert tan to sin upon cos. 1 plus sin 17 upon cos 17. 1 minus sin 17 upon cos 17 equal to tan 62. Take LCM and then cancel the cos terms. Hence proved. Okay. For question number 16, I'm just giving you the hint. 2a plus 3a. 2a plus a is equal to 3a. Now take tan on both the sides. Question number 17, again I'm giving you the hint. 45 plus 30 is equal to 75. Now take tan on both the sides and you can prove. Okay. But then in question number 17, don't put the value of tan 30, which is a standard value. Don't put that. Only tan 45 one you can put. That is the end of exercise number 1 of compound angle.